Welcome to my masterclass on how to defeat the CMB and most of standard cosmology. The CMB is the strongest pillar from the Big Bang theory. Redshift and light element abundance are the two other pillars, but they cannot manage to hold the Big Bang theory on their own. Take away the CMB and the whole model falls apart. So I would argue, no. It's not the strongest pillar. The CMB is the weakest link. Because if you can defeat the CMB, you can defeat the Big Bang theory. You can defeat standard cosmology. So now I will talk a little bit about what the CMB is exactly, why it likely comes from the oceans, and why it likely comes from outer space. If you're confused right now, that's exactly the problem. Because the CMB stands for two things that are very often confused with each other. Two signals, two microwave background signals that are measured typically with different instruments. Namely, the black body microwave backgrounds, I will call it the BMB, just to make it very clear that it's different from the other one. And this is what they also call the monopole in astrophysics. This is, let's say, everything that has to do with this black body radiation. And then the fluctuations on this black body radiation, that's the A and B, the anisotropic microwave backgrounds, typically presented with this anisotropy maps. These are the multipoles that they very often talk about in terms of the CMB. Very important to make this distinction between BMB and AMB. And now you can resolve this picture a little bit further. You can now see that the BMB is the strongest pillar of the Big Bang theory. Because if you take away the BMB, the A and B, with the other two pillars, are not strong enough to hold the Big Bang theory. And by the way, this is nothing, there is absolutely nothing controversial about this. You can just take whatever standard cosmologists from the street. They will agree with you. It's the BMB that really should matter here. The black body radiation. If A and B is not coupled to black body radiation, your whole model collapses. So, the BMB is the weakest link for the Big Bang theory. Very important conclusion. Because we can simplify the discussion quite a bit. The A and B on its own does not provide any direct evidence for the Big Bang theory. So, let's focus on the B and B possibly coming from the oceans. Here, Pierre is differing from the standard cosmologists. So, European Space Agency and NASA, all standard cosmologists are very much agreeing that both the BMB and the AMB are from the same origin, namely the Big Bang, relic radiation from the Big Bang. While Pierre says like, no. You have to split them up. And the BMB comes from the oceans, and the AMB, I paraphrased here a bit, it's an ill-defined space signal. I think that kind of captures what he means with it. I try to at least give here a little bit of perspective, like, still might come from space somehow. And then here's the real kicker. You don't have any direct evidence that BMB comes from space. And that's where the argument basically should end. But most cosmologists still believe there is this evidence. So let's break it down a bit. Here I try to summarize most of the measurements that have been done. So in 4 categories, you have the earthly detectors, you have then 3 satellites, COBE, WMAP, and Planck. And very important to know is where they are located. The earthly detectors are obviously located at Earth, then COBE very close to Earth, 900 kilometers is close enough to still have access to this radiation from the oceans. And then you have WMAP and Planck, which are located at the second Lagrangian point, which is 1.5 million kilometers away, as we already saw in one of these comments before. So that's a little bit too far away to receive this radiation from the oceans. So that's exactly what Pierre-Marie also says. The first 2 categories of instruments, COBE and the earthly detectors, can measure the BMB because they're close enough to Earth, while WMAP and Planck, they cannot measure it because the second Lagrangian point is way too far away. And so here you see a summary of what these instruments were measuring. So Nothing special about the first row there. This is exactly what Pierre-Marie Robitaille said in the previous slide. Earthly detectors and COBE can measure the BNB, WMAP and Planck, they cannot. They were not even designed to do it, so nothing really special about it. So here, let's have a look at the symbols. A green V means that it was measured. Red cross means it was unable, the instrument was just unable to measure it, or was just not designed to measure it. And then the red flag is problem for the Big Bang theory. It should have measured it in principle. Then it's a little bit more complicated than just direct measurement of the BNB, because you also have something like an indirect measurement through the dipole, one of the multipoles. And this dipole is the first derivative of the monopole. So in principle, you can calculate the monopole from it. And there you see that only COBE was actually measuring the BNB in that way. But there is a little red flag there. Why? Because through these two methods, the direct method and the indirect method, they were measuring different temperatures. And significantly different, because look at the error bars. Look at the errors at these numbers. They're so small, because this was one of the most perfect measurements of a black body. Actually, the most perfect one that humans ever performed. So these error bars, they don't overlap, and this is actually quite significant. So here is a quote from Pierre. These uncertainties are at the 1 sigma level. The difference between these two numbers remain highly significant even at the 99% confidence level. So this is a problem for cosmologists. And even this indirect measurement does not prove that the BNB comes from Earth at all. So it's actually just a little red flag. I would not consider this to be as significant as the other red flags that we will discuss immediately. Then you have also this comment on criticism on Pierre-Marie's work. The COBE probe was located much closer to the Earth, 900 kilometers above the surface. It was measuring only in the direction away from the Earth. Very important. So its measurements are consistent with those done by WMAP and Planck. So the relative proximity of the oceans had no impact on the results. Seems like a reasonable comment until you begin to think a little bit more according to physics. So this is this COBE satellite. Very important is this gray shield that we will immediately talk about. And then you have NASA saying things like, the far infrared absolute spectrophotometer, so this FIRAS that you see in the picture, instrument precisely measured the spectrum of the cosmic microwave background, showing that it matched a black body, a perfect emitter and absorber with a temperature of 2.725 Kelvin, providing strong support for a hot cosmic origin. COBE had produced the first baby picture of the cosmos. Statement, no doubt about it anymore. However, there is something called diffraction. The effects of signal diffraction into FIRAS, while considering the Sun-Earth radio frequency shield, so this gray thing there, were neither measured nor appropriately computed. Diffraction of earthly signals into the FIRAS phone could explain the spectral frequency dependence first observed by the FIRAS team. So COBE doesn't prove anything about the origin of the universe. The signal that it measured could just come from Earth through diffraction. So where, again, is our solid evidence? Where is this baby cosmos? I have to come up with new flags because a red flag is not really appropriate for this one. So I thought maybe we should use a baby blue flag to symbolize the argument's maturity. Like, oh, COBE is a good argument for the Big Bang. So here we get it. 2 blue flags with the early detectors and COBE, because they did not exclude any earthly sources in their experiments. They cannot prove these experiments. They cannot prove that the BNB did not come from Earth. But then you still have these other two red flags. The WMAP and Planck satellites, which had differential systems analogous to the DMR on COBE, should have been able to measure a dipole. And if so, we should be able to calculate the value of the monopole at the second Lagrangian point, but unfortunately that never happened. Instead, the teams from WMAP and Planck, they used the data of COBE to calibrate their dipole. This tells you a lot about how trustworthy they think their own instrument is. They cannot even isolate the dipole from it and say, like, we're now going to compare it with COBE and see how well they compare. And so to summarize, the early detectors and COBE are inconclusive about the BNB origin, and WMAP and Planck, they only focused on the A and B, so they cannot really be used as a strong argument in favor of the Big Bang theory.